All right, here is page 2 of the log equations worksheet. So I went through and worked these problems in the first video. I'm going to work these ones in this video. So this problem is kind of a mess. You might recognize it from your homework. A lot of logs floating around, which makes it kind of challenging. You see all these log-based 2's, and you might think a good strategy from the start would be to do 2 to both sides of the equation. But actually, I think it'll benefit you to use a log rule first. Could rewrite this as the log base 2 of x to the 7th power divided by x to the 3rd power divided by the log base 2 of 2x equals 3. So that's using my second log rule to make this difference of logs into the quotient of a log. The log of a quotient, I guess. And that gets me here. And from here, how much room do I have? Plenty of room. X to the 7th divided by x to the 4th. Sorry, x to the 7th divided by x cubed is just x to the 4th. And at the risk of doing 2 steps in one, I'm going to multiply both sides by log base 2 of 2x. So I got 3 times the log base 2 of 2x. If both sides were just log base 2 of something, I could get rid of them by doing 2 to both sides of the equation, but this 3 is kind of annoying. But I can get rid of that 3 by moving it up into the exponent by using my third log rule. That gets me here. And now I can do 2 to both sides of the equation to get x to the 4th power equals 2x cubed. And 2x cubed is 2x times 2x times 2x, aka 8 times x cubed. And now, most people divide both sides by x cubed, which really you shouldn't do because you lose information. You lose 0 as a possible solution. Really what you should do, although I know nobody does this, is subtract 8x cubed from both sides of the equation and then factor an x cubed out from each of these terms. Whoa, what happened to my... Oh, no, that's right. To get to here. And now you got something times something equals 0, so either x cubed equals 0 or x minus 8 equals 0. X cubed equals 0 when x equals 0. X minus 8 equals 0 when x equals 8. But it turns out x equals 0 is not a solution. And the reason why is if you tried plugging it back in, you'd be taking the log base 2 of 0, which is undefined. So really, when I planned on dividing both sides by x cubed here, I would have lost this as a possible solution. But it's not a solution anyways, so it wouldn't have mattered. But technically, it's probably a better habit to do things this way. Even though, again, I know nobody does. Okay, 2 to the 2x power equals 20 to the x minus 1 power. This problem's kind of challenging, although maybe not as bad as some we did on the front page. But one challenge with it is that we have 2 different bases for our exponents. So what do you do in a case like this? Well, you kind of have some options, but I just take the log of both sides of the equation. Which log you take is totally up to you. Take the log base 2, you can take the log base 20, you can take the natural log. Maybe I'll take the log base 2 this time, why not? No, I'm going to take the yeah, I already did it. I'll take the log base 2 of both sides of the equation. That gets me here. This side's in good shape, but on this side, I still have this x up in the variable, or this variable up in the exponent. Man, I gotta stop making these. I'm getting tired. So I'll use my third log rule to bring that down in front and get x minus 1 times the log base 2 of 20 is equal to 2x. And now all my x's are down on the normal line, I guess. So I just want to collect them all on one side of the equation. And to do so, I need to get rid of these parentheses. So I'll take this log base 2 of 20 and distribute it through. Get 2x equals x times the log base 2 of 20 minus 1 times the log base 2 of 20. So now I can subtract this x. Well, to keep things positive, let's add the log base 2 of 20 over to this side. And subtract the 2x over to this side. And then factor out an x. Should be consistent. So now to finish, all I got to do is divide all this junk over to this side and get x is equal to the log base 2 of 20 divided by the log base 2 of 20 minus 2. And if you really felt like it, you could probably simplify this thing quite a bit. Maybe I'll do so, but I'll say it's like optional. Or, let's see, this is the log base 2 of 20. And down on the bottom, this is the log base 2 of 20. And negative 2, well, I could write that as minus the log base 2 of 4. Like, why would you write 2 as log base 2 of 4? Well, we agree that 2 is the log base 2 of 4, yeah? And if you'll buy that, then what I can do is apply my third log rule to say that log base 2 of 20 minus log base 2 of 4 is the log base 2 of 20 divided by 4. But 20 divided by 4 is just 5. So I got log base 2 of 20 divided by log base 2 of 5. I could use the change of base formula, kind of in reverse if I wanted to say that this is just the log base 5 of 20. I don't expect you to do all this simplification. Had you worked this problem in a different way, you might have gotten this answer in the first place. Maybe, maybe not. I don't know. But it is a correct answer. If I did it, yeah, I think I did everything right. So either this or this, call them both good. Word problem. Find the doubling time of a sample that grows at a continuous annual rate of this. Okay, I guess for this, you want to know that if you have a continuous growth rate, you can model it with this. Let's use the letters that your book uses. That P of t, which is the amount you have at time t, equals P naught, the amount you start out with, times e raised up to the r times t power. So the doubling time, wait, it doesn't tell me how much I start out with. Then start with whatever the hell you want. Start with 1 maybe, and figure out how much time it'll take to end up with 2. You'll get the exact same answer if you started out with 100 and ended up with 200, or start out with 11 and ended up with 22. It doesn't matter. E raised up to the r, the rate is 7%, so I'm going to put a 0.07 t in here. And so now to solve this, just take the natural log of both sides. Get natural log of 2 is equal to 0.07 t, and therefore t is equal to the natural log of 2 divided by 0.07. So for part 1, or I guess, find the doubling time, that time right there. Determine the annual growth rate of this sample. Okay, so what you need to know for the annual growth rate is to solve it, you're kind of solving for b, really it's 1 minus, or b minus 1, in the formula y equals a times b raised up to the t power. So this b right here is the annual growth rate. So what you can do is kind of use the information we figured out here, that after this much time, if I start out with 1, I will end up with 2. And this much time is what would go up here. So up here in my exponent, I got the natural log of 2 divided by 0.07. So if I could solve this equation right here for b, then I'd be in pretty good shape. Right? This is just a number here. So if I could solve this thing for b, I'd have my answer. Well, that's not entirely true. B minus 1 is my answer. So let's solve this for b. Well, first of all, you don't need to write this 1. Natural log of 2 divided by 0.07. This is kind of cheating. Maybe I should use a calculator. If I raised both sides of the equation to 1 divided by this, it would cancel out on this side and it would show up on this side. So I got 2 raised up to the 1 divided by this power. Well, 1 divided by that is this. So this value right here will end up being my value of b. And so my growth rate, annual growth rate, is equal to b minus 1, which is equal to 2 raised up to the 0.07 divided by the natural log of 2 power minus 1. If you want to show off, express this answer. That's funny. This was supposed to go with, I guess it's not that funny, h up here. And in fact, I did that. This was supposed to refer to this. So I'll have to move that around on the worksheet that I send you guys, or that I give you guys. Okay, I guess that jumps me down to k here. K, I haven't shown you how to do this. There's no reason you should know how to do this, but you can do it. If you read through this, it kind of gives you some hints. It says first use log rule 3. Well, log rule 3 is the one that says that you can take exponents and move them down as coefficients, exponents inside of a log, and coefficients in front of a log you can move up into the exponent. Well, there's no coefficients here, and the only exponent that's inside of a log is this one. So when it says first use log rule 3, it must be referring to that. Note that log rule 3 does not apply on this first term because it's not the x that's being squared, it's the log base 2 of x. So if I were to use the first log rule, I would have the log base 2 of x squared minus 2 times the log base 2 of x minus 8 equals 0. Okay, that's the third log rule, but I don't see how that helps. Well, here's the next step. It says let y equal log base 2 of x. So I got a log base 2 of x right here. I can substitute in a y. Minus, I got a log base 2 of x here, so I can substitute in a y. Gets me here. I can solve this equation. This thing factors. Y minus 4, y plus 2 is how you factor this trinomial, quadratic trinomial. I think I'll just assume you know how to do that. If you don't, I can show you that in a different video. So now you solve, you got something times something else equals 0. And that can only happen when one of those two things equals 0. So either y equals 4 or y equals negative 2. And you're like, wait a minute, it says my answer should be a whole number and a fraction. I got two whole numbers here. What went wrong? Well, you didn't solve for x, right? You solved for y. Y is something that we made up. Y is the log base 2 of x. So really it's the log base 2 of x equals 4 and the log base 2 of x equals negative 2. And I could solve these two equations by doing 2 to both sides of the equation. 2 to the 4th power is 16. 2 to the negative 2 power is 1/4. So these end up being the two solutions here. I think it's time for me to end this video.